Okay, let's finish up graphing quadratic inequalities. This shouldn't be too long of a video. We're just going to look at a different type of quadratic inequality, which is where you look at it as a function with an x and a y value. So instead of just solving for x now, we have x and y values, and we're going to see what part of the graph makes this inequality true. So we don't have to draw a perfect graph here, since we're not really looking for that. We're just looking for what area of the graph makes the inequality true. So it'll be good enough to just draw, say, the x-axis, and then draw a general look of what the parabola, where it's going to be. So let's just find the roots here. So if we set this part of the expression, this expression equal to 0, and factor it, the roots will be -3 and -2. So if we draw our y-axis there, they're both negative, so the parabola is going to look, well, they're a little closer together than that. It's going to look something like that. It's about what it looks like. Now, this part of the parabola should probably be crossing the y-axis somewhere, but not a big deal. The roots are generally in the right place. What we're looking for is what section of the graph makes this inequality true. And a lot of times people will overcomplicate this with things like test points, plugging numbers in, but really it's very simple. We have y greater than or equal to the expression being represented by the parabola as a function. So where is the y value greater than the parabola? Well, that would be in this area right here. Since the parabola is down here, then anywhere above this line has to be in this area. So let's just shade in that area. This whole area here is where this inequality is true. So same thing for this one. We're just going to factor it real quick to get a general idea of where the roots are, setting it equal to 0. We can first factor out a 3 from the whole expression. And then this will get x minus 2 times x minus 2. So x minus 2 squared, meaning we only have one real root here of x equals 2. So if that's the x-axis, this is the y-axis, and it's only have one real root, so it just touches the graph at x equals 2, looking something like that. So in this one, we want to figure out where is the y value less than the expression being represented by the parabola. And that would be below the line of the parabola. Below the line is where the y value is less than the line. But before we shade that area in, which would be this whole area here, there's one thing we have to remember, which is that because we do not have less than or equal to in this inequality, only less than, it does not include the line. In this parabola, in this inequality, it included the line because the shaded area could be greater than or equal to the line. But because it does not include the line, we want to draw the parabola as a dotted line to show that the line of the graph itself is not included in the inequality. It has to be less than the graph. And then this whole area out here surrounding the graph is less than the expression. Okay, so here, same thing, we're just going to factor it. We can start by factoring out a negative from the leading coefficient. And again, we're just factoring here, so we get a general idea of what the roots are. So we're going to factor inside the parentheses here. Let's see, I haven't done this one yet, so you know what? I think it's going to be 2 and 2 on that side. Yep. That is 6 plus negative 10, which is negative 4. There we go. So the roots here are going to be negative 3 over 2 and 5 over 2. So the graph will look something like that. Actually, wait a minute. Sorry, the leading coefficient is negative, so it will be flipped upside down. That's very important to remember for the inequalities. Now notice they can be less than or equal to, so since it is or equal to, it includes the line, so we draw a solid line. And now we're looking, where is it less than the line? Well, unlike in this one, where less than meant outside of the graph, because in this one the graph is pointed downward, less than the graph means below it, which is inside the parabola. Okay, let's just do one more, since I think this is pretty straightforward at this point. So we want to get a general idea of what the roots are, so we factor out a negative from the front. Okay, so that's not going to work. 1 and 4 is not going to work. Let's try 2 and 2. Yeah, this is not working. And intentionally so, because this one is unfactorable. After a while, you'll realize that. So when a quadratic is unfactorable, it either means that the roots are non-rational, meaning they have a square root or something like that, so you're not going to get them by factoring, or it means that there are no real roots, in which case you'd get an imaginary number when you factor it, or when you use quadratic formula. So we don't waste our time in case that is the case where they're imaginary roots. We can just check real quick using the discriminant. This will show us if they're real roots or imaginary roots. So discriminant, we'll check that real quick. B squared minus 4ac. So this is going to be 64. Negative times negative is negative. And 4 times 4 times 7 is 28 times 4 is 112. So that is a negative number. Negative discriminant means there are no real roots. The roots are imaginary. So the graph is going to look something like this. It's pointed downward because of the leading coefficient being negative. And because the roots are imaginary, it does not touch the x-axis. So it looks like that. So now we're looking for where is the y value greater than this line. Well, greater than means above the line, so it would be up here. But it also means it does not include the line. So let's make sure to draw the parabola as a dotted line. And now we can show that greater than means above the line, not including it. This whole area up here. Okay, and with that, we are done with quadratics. So In the next video, we will get started with a brand new unit and start looking at higher degree functions, functions with powers higher than 2.